like for us to do is I'd like for us to look at a table where we're given that the information in the table is linear information. Our function f is linear. So we're going to learn to answer some questions about this particular table. And in order to do that, we're first of all going to have to find a linear equation that represents this information. So we know that we have to start by identifying a slope or a rate of change and a y-intercept for a linear function in order to write a function relation that describes the data. So let's begin by doing that. I want to first of all calculate the rate of change, and notice in the table there are two convenient pairs of data, x's and y's, from which we can form coordinate pairs, ordered pairs, and we'll use these two rows in our table to calculate the rate of change. So in doing that, our equation, m, which is our rate of change, would be 5 minus a negative 7 over 6 minus 0. Well, let's evaluate this numerator denominator. So 5 minus negative 7 is 5 plus 7, which is 12, and 6 minus 0 is 6. So that results in a rate of change of 2. So we know that m, our rate of change, is 2. Well, we're going to write an equation in slope-intercept form using function notation. But in order to do that, we also know that besides having a number for rate of change or slope, we also need a y-intercept. Notice in this case that the table provides us with the y-intercept because the y-intercept always occurs where our independent variable value, x, is 0. So we know the y-intercept in this case, what we use for b in our equation, is negative 7. And we get that value directly from the table. Now we have enough information to write an equation in slope-intercept form. Since we're using function notation here, we'll continue with that and say that f of x is equal to 2x and then our y-intercept minus 7. So this equation describes the data in the table because we knew it was linear. So let's stop and think for a moment. The information in the table has some values missing. Notice that here we're given an x and we need to find an f of x or a y. Here we're given an f of x and we need to find an x. So two things are going on in terms of finding answers to the questions, what's the missing values from the table? Number one, if we're given an x, how do we find an f of x? And then number two, if we're given an f of x, how do we find an x? So let's set out to answer those questions. First of all, I'd like to find the missing f of x that's associated with the value of 2 from our equation. So to find that number that belongs in the table here, what we're going to do, we're going to substitute this value of 2 everywhere we see x in our function. So what we'll do, f of 2 is equal to 2 times 2 minus 7. So to evaluate, we get 2 times 2 is 4, and 4 minus 7 is negative 3. So the value that belongs in our table associated with 2 is the number negative 3. And notice we found that by substituting the 2 in for x in our linear equation. In this case, the row just below our value of 6, we're missing an x, but we have an f of x. So what we're going to do here is different from what we did in the previous example. We need to substitute 11 for f of x, not for x. We're trying to figure out what x is. We know that f of x is 11. It looks like this. So 11 equals 2 times x minus 7. Notice that we substituted 11 for the f of x in our original equation. So now we're going to solve this resulting equation. The first thing we'll do is add 7 to both sides of the equation using the the addition property of equality. So 11 plus 7 is 18, and that's equal to 2x. And notice here we have plus 0. We won't need to write the plus 0. The next step in solving the equation is to divide both sides by 2. And when we get that, when we get the result, 9 is equal to x. So we know for an input value that would output an 11, we're going to have a 9. We found that by substituting 11 in for f of x in our equation. Same type of calculation. We know that the output, f of x is 17. We need to find the input value that produces that 17. So again, we're going to substitute 17 for f of x and solve for x. In this case, 17 equals 2 times x minus 7. First step, to add 7 to both sides. That's the addition property of equality. 17 plus 7 is 24 equals 2x plus 0. I won't write the plus 0. Divide both sides by 2, and we get 12 is equal to x. So we know that an input of 12 produces an output of 17. What we just did was complete a table of values. In some cases, we knew an x. We had to find an f of x. In other cases, we had an f of x. We needed to find an x. And that happened in those two cases. So let's extend that to perhaps a problem involving something familiar from our recent working class. Let's suppose that we have a swimming pool that's draining based on the equation f of x equals negative 150x plus 5,000. So we have f of x is our volume of water in the pool. 150, a negative 150, describes how much the volume is changing each unit of time. And we'll say that our time is in minutes. So perhaps to make this really clear, the best thing for us to do is to stop and identify what these variables are. So f of x equals volume in gallons. X is equal to the time in minutes. Well, we might ask two questions related to this particular question, to this particular physical situation. And one of the questions that we might ask is, what's the volume in the pool at some time, x? So let's say x is 10 minutes. So if we ask, what is f of x if x equals 10, what we could do is substitute x in for the 10 in for x everywhere we see it in our equation, and then evaluate. That's like having an x in our table and looking for an f of x. Another question we might ask is, what is x if f of x equals 0. So here we have an f of x. Like we knew in the table we had an f of x. We're trying to solve for x. So these two questions involve different strategies. This equation, or this question, will produce an answer that's in f of x gallons. This question will produce an answer that's in x time in minutes. Let's go ahead and answer these two questions. What is f of x if x equals 10? So we'll use our equation. F of 10 equals negative 150 times 10 plus 5,000. So a little arithmetic. F of 10 equals 150 times 10 is negative 1,500 plus 5,000. Well, another little bit of arithmetic. We know that that's going to be 3,500 gallons. So f of 10 is, when x is 10, our f of x is 3,500 gallons. Let's go on to answer this question now. What is x if f of x is 0? So notice we're given an f of x, and we can replace f of x in our equation with this value. So we have 0 equals negative 1,000 or 150 x plus 5,000. First thing we're going to do is subtract 5,000 from both sides. So subtract 5,000, subtract 5,000, and we get negative 5,000 equals negative 150x. The next thing we need to do is divide both sides by negative 150. So the answer, 5,000 divided by 150, is equal to what x is. So if we were to divide 500 by 15, let's see if we can do that right quick. So we get to, 45, and 5, 50, 33.33 1/3. So we have x equals 33 1/3 minutes. And here we had gallons. So those two situations will allow us to deal with this pair of questions that some of you seem to have been struggling with. I hope that helps.